Welcome back to Math Concepts. We are continuing our work with compound interest. In this video we are going to discuss what is called a present value problem. In previous work we were given the amount that we were going to deposit and then how long we're going to wait. And then we wanted to see what we end up with after that time is over. So in other words, we wanted the future value of our money. We know what we have now. We wanted to know what we were going to end up with. We're going to reverse that in this video. A present value problem is when you know what you want to end up with. And you want to say, what do I need to put in the bank today to make that happen? So what do I need today? I know what I want in the future. What do I need right now? So present value problems. Let's go to the document camera and look at an example. Alright, so the key idea from this video is I want you to understand how to compute the present value of an investment. And once again, that's when we know how much we want down the road and we're asking how much we need today. So this example. How much money should be invested in an account that earns 9% interest compounded semi-annually so that we have $20,000 in 6 years? Okay, so this is our target amount. That's what we want to end up with. Now, let's look at what we know. We know this formula for computing the compounded amount. Okay, what we're going to do is we are going to fill in all the known values. Okay, we're going to fill in everything that we know. So let's go down here. Now we don't know the principal. We're going to leave that blank. We do know the amount that we want to end up with. The amount we want to end up with is $20,000. Principal is unknown. That one, okay, remember that's always there. When you're dealing with compound interest, you keep everything you have, 100%, plus additional. R over N, 0.09. Once again, we convert our interest rate from percent notation to decimal whenever we're doing computations. Compounded semi-annually, that means we have a 2 there. Okay, semi-annual compounding means twice a year. We're doing semi-annual compounding for 6 years, that means my exponent should be a 12. Got to take this and solve for P. Alright, well P is multiplied by this thing right here. How do you get rid of a multiplier? Well, you divide. So to solve for P, I should take 20,000 and divide by this business right here. Alright, now the good news is we can just compute this on our calculator by inputting that expression exactly as it looks. Okay, we're going to take 20,000, that's 2,000, so we want 20,000, divided by, left parenthesis, 1 plus 0.09, divided by 12, right parenthesis, exponent, 12, equals. Okay, so it looks like the amount is $18,284.76. Alright, so the thing to note here is notice that of course this is less than the 20,000, okay? And that should make sense. Okay, that's the way the answer should work out. We're going to deposit a smaller amount into the bank account. We're going to let it earn interest for 6 years, and then it will grow to this amount. Okay, so this is a way to deal with a present value problem. You know the amount you want to end up with. You don't know what you're supposed to deposit today. In other words, you don't know the principal. So you fill in everything that you do know and solve for that one unknown. All right, some people like to write out the present value formula. And that goes like this. It's the amount you want to end up with, 1 plus r over n power nt. All right, that just summarizes the steps we did right up here.